In this video, I want to walk through the solutions for the Precept 1 problem set. So problem 1 is to just define a vector with those contents and store that vector in my.back. So let me do that. So I'll just copy this and I'll create a vector. So the way you create a vector is using C. All the values need to be comma separated, and finally we'll say my_back and we'll store the vector in here. So note that you can get the value this way. So I just highlight the part that says C42 and so on, and you press Control Enter or Command Enter depending on whether you're on a PC or a Mac, and you get the vector here. If you assign, so here the cursor is just in line 1, I'm pressing Control Enter, Command Enter in the Mac again, and now my vac has been defined. So if I want to query the value of my vac, I can do that like that, and you can also see it here if you click on the Environment tab. So that's the definition of my vac. The question next asks about the difference between my.vac and my.vac in quotes, so something like this. So the answer is that my_vac, that's a variable. So if you type in my_vac here, what you'll see is the actual values in the vector, so 42, 43, and so on. On the other hand, my.vac, that's a character. That is literally the text my.vec. So what you'll get is just this if you query for this value. Next up, what we're asked to do is we're asked to write a function. So we want to write a function that takes in a vector and returns a new vector that contains the second and the fourth elements of that vector. So the basic structure of a function looks like this. So first comes the name of a function. So here there's not a particular name that we need, so we'll pick just something that makes sense. So maybe something like lms24 or something like that for second and fourth element. And then we'll say that lms24 is going to be the function that's going to take in a vector. So here we say VEC because we know it's going to be a vector. However, this is arbitrary. We could have used any name at all that works. And now we need to return the second and the fourth element. There are a number of ways of doing it. So here's how I'll choose to do it. So I'll say return, and then I'll create a new vector. And this vector will contain vac2 and it will contain vac4. So notice that the structure here of this thing is exactly the same as the structure of this. The only difference is that here I used literals, so the numbers here, they're called literals. On the other hand, here I got vac2 and vac4 from this variable vac. Let's see how this is going to be used. So after I define this function once, don't need to redefine it again, I can say something like lms24, and now I can supply, for example, my_vac like this, and I'll get the second and the fourth element. So that worked. So what happened here? So my_vac got sent to vac. So inside the function, what happened is we first computed vac2 and vac4. So vac2 was 43, vac4 was 49. We then created a new vector that contains the two elements, 43 and 49, and then that got returned. So that means that the value here was assigned to this expression. So this expression had this value because this says return, and then whatever is being returned from the function, that's the value of this expression here. What do I mean, the value of the expression? So if I assign this to something like res, like so, I could do that. And if I run this now, then res is going to be 43, 49. Why? Because first we sent my back to back, we computed 4349 here, 4349 got assigned to this whole thing, and then this whole thing got assigned to res. So res ended up being the vector 4349. So, okay. The next question is to write a function that outputs the solution to the quadratic equation. So ax squared plus bx plus c equals 0. And we need to test this function. So let's do that. So this is a larger function. So what I want to do is I want to go step by step before I actually write the function. And you should probably do that as well. So how do I solve the quadratic equation? Well, so to remind you, things will look kind of like this. So you would say minus b, and you would say plus or minus. So here I'll write plus or minus as plus slash minus, but this is understood to be plus or minus, right? And then you say square root of b squared minus 4 times a times c. So I write it as 4 times a times c. So it's a common mistake to write just like 4ac. R, of course, does not understand that. If you want to say times, you got to put the asterisk in. And then all of that needs to be divided by 2 times a. And I'll take care to, even in the formula, which is not in our expression, to actually write times here again. So what does this mean? It means that that's just the formula for the solutions of the quadratic equation. So that means that if we're trying to solve this quadratic equation, so a x squared plus bx plus c equals 0, that means that the first solution, R1, that's going to be minus b plus all of that divided by 2a, like so. And then the other solution is going to be minus b minus square root of b squared minus 4ac. That's going to be R2. So that is, of course, if there are two solutions. In what situations might there not be two solutions? Well, if it so happens that this is just 0, that means that it doesn't matter if you add it to b or subtract it from b, it's going to be the same. So this is going to be two solutions. And you'll have one solution if it so happens that this thing, so this is called the discriminant, is equal to 0. And then the one solution is just going to be minus b plus, well, this whole thing accepted 0, so it doesn't matter. So it's going to be just minus b divided by 2a. And there are no solutions if b squared minus 4ac, the discriminant, is smaller than 0. Why? Because, well, you cannot take the square root of a negative number unless you do something kind of more advanced. But here we just say there is no solutions if b squared minus 4ac is smaller than 0. So how should we proceed here? Well, we have 3 kinds of situations. So let's treat them one by one. But you'll notice that we keep kind of computing this, so it might make sense to compute it just the once. So we'll say discriminant is b squared, or I could write b squared like this, minus 4 times a times c. So now that's saved. And now we just go case by case. So if discriminant is greater than 0, that means that there are two solutions. And for now, we'll just print them. We'll deal with actually writing the function later on. So we'll say, okay, R1 is this, so we just copy this. So conveniently, we actually did kind of write all of that in our notation anyway. And we'll say that R2 is this. At this point, what I want to do is I just want to print the solutions. So that's going to be R1 and R2. So I don't want to do anything too sophisticated. At this point, I've written 5 lines of code, so it's actually time to test the code. Here, there is a bit of a problem in the sense that I need to actually come up with A and B and C, that kind of makes sense. So the trick that we saw in Precept was to say, well, I can come up with something like that. So I can say, well, like what happens if I multiply like x minus 1 by x plus 2, for example? Well, what I would get is x squared, so this is minus x, this is plus 2x, so plus x minus 2. And the roots here are going to be, well, those are the values of x for this, for which this is 0, which is 1, because 1 would make this 0, and minus 2. So 1 and minus 2. So here, this means that A is equal to 1, and B is equal to 1, and C is equal to minus 2. So I'll just assign those values. So this is just for testing. Obviously, kind of we want to make things general at the end. So A is 1, and B is 1, and C is minus 2. And you should follow the strategy generally. So you should just say, well, like, I'll just set the numbers to be something concrete, and then we'll see after we make this chunk of code work. So I've defined those. Now I'll see whether this works. So again, Control Enter or Command Enter. So I can check what the value of disk is. So disk, remember the discriminant. And now let's see if this works. So I'll say if disk is greater than 0, that seems to be true. I'll compute R1 and R2, and as you see, those actually got printed out. They also got defined. So R1 here is 1, and R2 here is minus 2. So all is good. So next up, I want to do something for disk equals to 0. So I'll say else if disk equals to 0, so that would be one solution. So I'll say R is, so I could just copy this, but to be a little bit nice about it, I'll do this. So just minus B divided by 2A. And again, I'll print R. So you might like to test this as well. So in what kind of situation would this happen? Well, not for those values, but if you do, for example, x minus 2 squared, that would be x squared minus 4x plus 4. So x squared minus 4x plus 4, like so. So I'll compute the discriminant. I'll see that it is indeed 0. And now I'll try to run the whole thing. And as you see, yes, indeed, the answer was 2. So that works, and you can check that that works. At this point, I want to review the structure here. So all the elements here, really, with some very few exceptions that we need concern ourselves with, they're necessary. So here, what we're saying is if disk greater than 0, so this needs to be in parentheses, and then what happens if disk is greater than 0, that's enclosed in braces like so. So if disk is greater than 0, then this will happen. So we'll compute R1 and R2, and we'll print out R1 and R2. And then it says, well, like if this did not work out, then we go on and check whether disk is equal to 0. And here, a common mistake is to include just one equal sign. This should be 2. If you're comparing, it's 2 equal signs. If you are not comparing, it's 1. So here we're saying if this did not check out, so if this was false, then we check whether this is going to be true. And if it is true, then we compute R, and then we print R. So there are no other possibilities. So if it's not 2 solutions and it's not 1 solution, it's 0 solutions. So we'll say no solutions, like so. And again, we can test whether this works by making up something like, for example, x squared plus 4 would not have any solutions because that's always positive. So x squared plus 4 equals 0 will not have any solutions. And if we run the whole thing, we'll see that indeed we printed no solutions. So okay, we developed the code. At this point, what we want to do is we want to actually make it into a function. So as a first step, let's decide on the name of the function. So let's say that we call it like quadratic. solution or something like that, or let's do it here to the style guide. We will call it something like quadratic solution like this. Now we'll say function, and at this point we need to decide, okay, so what information does this function actually need? So the information that this function needs is a and b and c. If you have a and b and c, then you can solve the problem. So we'll say a and b and c, like so. And here I'll just close the brace and I'll indent it. So indentation is not strictly speaking necessary. You can do without it and R will not complain. However, indentation makes things readable. So the block of code that's contained in the function, I would try to make sure that it is indented like this. So the way I did it is I highlighted everything and I pressed tab. So okay, alright. So here we're computing disk and we're printing things, different things, depending on what disk is. So let us now try to use this function. So I'll pick, for example, this set of coefficients a, b, c. And usually if I use the function, I would write the code for using this function below. So the way I would use it is I would say quad solution, and then I'll say, I could say a, b, c, for example. So let's try to do that. So the reason I got this error is because I forgot to define this function. So I highlighted the once, or I press source and then I don't need to, but I highlighted the once and I press Control Enter. Now it's been read in here. So now I'll try again. A and B and C have already been defined, and I got my solution here, 1 and minus 2. Now I could of course also just say 1, 1, minus 2. That would result in the same thing because A, B, C was equal to 1, 1, and minus 2. I could mix it up. I could say 1, B minus 2, and that is the same thing. So what's happening here? So what's happening is that this A, which is not exactly the same kind of thing as this A, those are different variables, but this A, the value of it rather, gets assigned to A, and the value of this gets assigned to B here, and the value of this gets assigned, of the C, gets assigned to C here. At that point, this gets run, that gets run always, and then depending on whether this is greater than 0 or equal to 0 or neither of those, either this happens where we print the solution here, or this happens, or this happens. So okay, that was the function. So what are the elements? The name of the function, assign the word function, the keyword. Now the list of the parameters that the function gets, so the information that the function needs in order to compute whatever it is we need to compute, is here, and then within the braces is the body of the function. Now this function is atypical because here we are not returning anything. Here we're just printing something. Usually, and in all future precepts, I am actually asking for you to return things rather than to print them. Here the instructions were a little bit ambiguous, so you could do either thing. So let's actually return something. Specifically, let's return a vector of all the solutions, all the real solutions for the quadratic equation ax squared plus bx plus c. So how do we do that? So I'll write another function. I'll copy and paste in the previous one. I'll modify it. I'll call it quad solution 2. So here, rather than say cat, I'll say return, and I'll say C are 1 or 2. And here I'll say return C R. So that is not really necessary. I could have just said R. So one subtlety about R, the capital R, is that everything is a vector. So this is a vector as well. It's just that it's a vector of length 1. So I'll just say return R. How do I return an empty vector? Well, one way to create an empty vector is to just say C. So I'll just say return C, like so, and click the empty vector, and now it's the same thing. So now that's going to be like this. I'll define it. And let me try to run it. So here's what happens. I get 1 and minus 2. All is good. Now, one thing that people sometimes fail to see is that if I just define this, I don't get any output. The function just gets read in. Why is that? Well, because it doesn't know what a and b and c are. It's just a function that you can then use, for example, like this, or of course, like this. So this tells it that a is 1, and b is 1, and c is minus 2, and then everything gets run, but just because you said this. Before you said this, nothing is going to run. The function is going to be defined, but not run. This is the same thing as when I say something like f of x equals to x squared in math. So this is how you would define a function in math. But of course, you would not expect that just because you wrote this down, this is associated with any particular value. If you plug in something for the x, then of course you'd get the value, but not otherwise. It's the same here. If you plug in something for a and b and c, you'll get something in return, because here it says return, so it'll return this if this is greater than 0, or this if this is equal to 0, or the empty vector otherwise. But if you just define the function, you won't get anything back. So, okay. We will do problem 3 in the next video.